Hi folks, Jim Randolph here, and I'm glad to see you're interested in saving money on your electric bill. I'd like to take this opportunity to explain how this power-saving device is going to reduce your electric bill every month. It all starts with something called power factor. I know you haven't heard this term very much, so I'm going to start off with the definition of it. Power factor is defined as the difference between the power needed to perform work and the electrical energy needed so the work can be performed. So now with the technical side of that definition out of the way, I'd like to explain this in a language that you can understand a little easier. Okay, the power needed to perform work means that if you had an object in front of you that you wanted to move, and you wanted to exert the least amount of energy to move that object, you would probably take both hands, about shoulder width apart, place them on the object, lean forward, and use your legs, your back, and your arm muscles to push as hard as you could. That would be an example of 100% power factor, meaning that your muscles, the position of your hands, and the angle that you push are all working together simultaneously. Now, the electrical energy needed so the work can be performed is where the power-saving device comes into play. If we took the same example we used a minute ago, where we had both hands on the object, and we made it so that we only had one hand on the object off to the side, then our power factor would go way down because we only have this amount of our body to be able to push against that. And it would take a whole lot more power to transfer the energy in that object to make it move. That would be an example of poor power factor. So now that we understand how power factor works in real life, how can we make it relate to what happens in our homes and businesses? Now for this, we need to understand how the voltage and the power work either together or against each other. For this example, we need to think about a television set. With the tracking that's off, you see all those lines that are going through your TV. Then you go up and you turn the little button one way or the other, and it makes those lines go away. By turning that button, it brings all of our sine waves back into synchronous form again. And that gives us optimal performance out of our TV. So how can we make this apply to our homes? Well, as our power changes, we'll take this actually from when the power comes into our home. So when the power comes into our home from the gas and electric company, it goes through our meter, and that's where the responsibility of the electric company goes away. We are responsible for what happens with the power inside of our home. The electric company is not responsible for that. They are only responsible for bringing us our power and our voltage like it's supposed to be to where our meter is. And what happens as it gets distributed throughout our house is our responsibility to take care of, not the power companies. I want you to know that nationwide, though, that the average power factor is only 77%. That's right, 77%, which means nationally 23% of the power we use is this hard, out-of-the-way power. It's wasted power. So, I don't necessarily like that we haven't been informed about this previous to this time, but I found out about it, so I know you need to know about it, so we can take care of this and we can keep some more of our money ours instead of giving it to the electric companies. Because I know I enjoy keeping my $800 and spending it on my family every year instead of giving it to the power company. So, how does this sine wave work, and how does this work in relation to our homes? Well, this would be a perfect sine wave right here. As our voltage and our power cross our median here, we actually want these to be right on top of each other. That would give us 100% power factor. There's here, here, and here. They cross exactly. All right? So now what happens is the voltage stays the same in our home, but as more motors come on, we need more power. And as that power we need more and more to push through, that power gets distorted. And so our sine wave, as more motors come on in our home, goes out like this. So when they're working out like this, we have a very poor power factor. And what will happen is, this is where we're out here pushing with one arm. And when we use our power saving device, we can bring this back in, just like we dialed in on the TV set. We can bring this back in the sink because our power saving device is sensing the electricity, the voltage, and the power in our home all the time. And that will come on and bring our sine wave right back in to sync again. That's what we need to happen all the time, because our refrigerators, our freezers, our washers and dryers, our furnace and air conditioners, ceiling fans, pool pumps, well pumps, all these different things that we have going on in our home all the time are using a lot of power, and there's a lot of motors in all these devices. So we definitely need the power saving device to come in and put our sine wave back in the sync again. Once we do this, you'll notice that your electric bill goes way down. You'll see that the little wheel on your meter goes from spinning real fast to slowing down. Thus, we pay less on our electric bill. Now, I know I put one of these in my homes, and I save 29% on my electric bill, and I am extremely happy with the way it's worked for me. Like I said, I enjoy spending that extra $800 every year on my kids instead of giving it to the power company. All right? So, the only last thing we have left to do is to get you signed up to receive one of these things, and we will have you installed in about 3 weeks. So please, click below. All the information you need is listed below here. Go ahead, invest in yourself, make a great savings, and stop giving your money away to the electric company. Thank you.